Under the subject of quality, reliability and engineering of a degree semester 7 in mechanical engineering department, today we are going to see the experiment number 13, which is a case study on Six Sigma. So first of all, let us understand what is Six Sigma. Six Sigma is a data-driven methodology aimed at improving process quality by identifying and eliminating defects, reducing variability, and enhancing customer satisfaction. It uses the DMIC, which is define, measure, analyze, improve, and control approach to achieve process excellence. In this case study, we examine how a medium-scale automobile component manufacturer implemented Six Sigma to reduce defect rates in fuel injector assembly line. So the problem statement is the company was facing a high rejection rate of 5.6% in the fuel injector assembly section, leading to increased rework and scrap cost, delayed deliveries, customer dissatisfaction. So the management decided to implement the Six Sigma methodology to bring the process within the acceptable quality limits. So as mentioned earlier, it is a five-step process. So first phase is define phase. In define phase, the project team defined the goal, which is to reduce the defect rate in fuel injector assembly from 5.6% to below 1% within 6 months. So for that, critical to quality factors were identified, which were dimensional accuracy of injector nozzle, proper torque of fastening bolts, leak-proof assembly of injector seals. So another step, they also draw the CPOC diagram, which is supplier input, process, output, customer, to understand the process flow. In second phase, which is measure phase, the data was collected from 10,000 assemblies produced over 1 month. The baseline process sigma level was calculated using defect data. So defect per million opportunity was identified as a 56,000, and based on this data, the current sigma level was calculated, which was 3.1 sigma. In third step or third phase, which is analyze phase, in this using Pareto analysis and Fishbone diagrams, the main causes of defectives were identified, which are improper torque setting in assembly tools, variability in seal material dimensions, inconsistent operator training, poor cleanliness of assembly area. So further to establish the statistical base, the ANOVA analysis was also carried out to show that torque variation and seal material inconsistency contributed to 70% of total defects. In improve phase, corrective actions were implemented like tool calibration. All torque wrenches were calibrated weekly. Supplier quality improvement. Seal materials were standardized with tighter tolerances. Operator training. Operators were trained for skill-based training. 5S and Pokayoke introduced mistake proofing mechanism and workplace organization. So after implementing these all corrections, after the defect rate reduced to 0.8%. So once the corrections have been implemented and we have achieved the results, so last and most important phase is control phase, means how to sustain these results. So for that, uh, control charts were implemented for key parameters like torque dimension. Weekly qualitative audits and feedback sessions were also conducted. Standard operating procedures were also updated. So after 3 months of control phase monitoring, the process stabilized at 4.4 sigma level, maintaining defects below 1%, which is 0.8%. So let's see how much the improvement the current case study the organization has achieved. So defect rate was reduced from 5.6% to 0.8%. Sigma level was increased from 3.1 sigma to 4.4 sigma. Rework reduction was of a 60%, customer complaints were reduced from frequent to rare, productivity was improved by 15%. So based on these results, we can conclude that the Six Sigma implementation significantly improved process capability and product quality. The project demonstrated that systematic problem solving using data and analyze tools can yield measurable benefits in manufacturing. The company is now planning to apply Six Sigma to other processes such as fuel pump assembly and carburetor machining.